Alright, so in this lesson we're going to talk about literal equations and dimensional analysis. Really the focus is going to be on the literal equations part of it. So we usually skip that part. We're just going to keep skipping that part. And we're going to go down to the review vocabulary. So identities are equations that are true for all values of variables. So this is when you get something always true. For example, 3 equals 3, or x equals x, or 0 equals 0. Another way we would write that is all real numbers. And then in symbols, it would be x exists in the real number system, or whatever variable you're using. Okay? We're not really worried about this next one. That's a pre-algebra topic, so we can cross that out. And here, a formula is a rule for a relationship between certain quantities, and it typically has more than one variable in it. So we talked about, I think before, something like area equals pi r squared. That's an example of a formula. It's got two different variables in it, a and r. All right, new vocabulary. Match each term with its definition. So dimensional analysis, again, that is the process for carrying units throughout a computation. We're not going to worry about that one too much. Something you might use in chemistry class in high school. That's where I remember it from. A literal equation is a formula or equation that involves several variables. So pretty much all formulas are literal equations. And unit analysis is another term for dimensional analysis. And we don't talk about that too much in here, but you will hear that term later at some point in your academic career. Okay? Literal is a word used in everyday English. Find the definition for literal using a dictionary. Explain how the English definition can help you remember how literal is used in mathematics. So the definition for literal, the dictionary says that literal means consisting of or expressed by letters. Okay, so in math, a literal equation is a formula or equation that involves several different variables or several different letters. So in math, a literal equation contains more than one variable. And those are usually represented by letters. So in math, a literal equation contains more than one variable, something like a equals pi r squared, and it's usually represented, these variables are usually represented by letters. Right, turning the page over, we have some examples. Page 52 there. Okay. So solving out a literal equation is pretty much just like solving a regular equation, except instead of solving for a number, you're solving for a variable. So in this case, we're going to take this literal equation, we have p, q, and r, and we're going to solve it for p. So the first thing that we need to do is isolate the term or terms with the variable into one side or onto one side of the equation. So if we're solving for p, I like to either highlight or circle the variable that I'm solving for. So in this case, I'm going to go ahead and highlight it. I'm solving for p. There's a p there, and there's a p there. So we need to get all of the p's on the same side of the equation. Let's see if I can zoom this in just a little bit for you. All right, so to do that, we need to move PR over to the left. So we're going to actually end up interesting. We're going to end up eventually moving this PR over here, but first we need to move the Q's to the other side. So we're using that addition property of equality. We have a negative 3Q and a positive 3Q, so those are going to cancel out. We're left with 4P is equal to PR plus 9 plus 3Q. So now we have a term with just a P over here, We need to get the other term with the p in it to the other side of the equation. So we can subtract PR just like you would do if they were numbers. So you subtract PR from both sides, and you end up with 4p minus PR is equal to 9 plus 3q. Okay. Then we're going to use the reverse distributive property. It's kind of interesting what we did here. Instead of multiplying out by p, you can actually pull the p to the outside. So you're reversing that distributive property. So we pull the p to the outside, and we're left with 4 minus r on the inside equals 3q plus 9 on the other side. So it's not necessarily distributive property unless you think about it in the reverse distributive property. All right. Next step, we need to get the p by itself. Again, we're still trying to isolate that p since we're solving for p. So we can divide out by this whole quantity 4 minus r. So 4 minus r in the numerator, 4 minus r in the denominator, they cancel out. So we're dividing each side by 4 minus r, division property of equality. They cancel out on this side, and you have the quantity in the denominator over here. And then we simplify, right? Those two things canceled out. So we had p is equal to 3q plus 9 and divided by 4 minus r. And r cannot be equal to 4. If r was equal to 4, you'd have 4 minus 4 in the denominator, which is 0. And we can't divide by 0, so we've got to be pretty careful about that. All right, helping you remember. When you give the dimensions of a rectangle, you may have to tell how many units long it is and how many units wide it is. How can this help you what dimensional analysis involves? We're not really concerned about dimensional analysis, so we can skip that. And then using formulas, the formula for the area of a rectangle is A equals LW, where L is its length and W is its width. Find the area of a rectangle of a garden that has an area of 5,400 square feet and a width of 90. That's really also not our topic today. That's more of a evaluating expressions. So to save a little bit of time, we can cancel that one out as well. All right, hopefully this helps you guys, and we'll move on to our next topic.